In the previous video, we did something called a zero imputation, where we fill the NA values with 0. So this is the basic step of data cleaning. If you want to replace the NA values with mean, median, you can do it yourself just by selecting any particular column, and if it is meaningful to replace the NA values with mean and median, just do it. Now here in our example, I thought replacing the NA values with mean and median doesn't seem meaningful, thus we impute it with 0 values. Maybe in the upcoming videos, maybe if we saw some example where we need to replace the NA value with mean and median, we will do it in the upcoming project maybe. But for now, this is fine. Now next step of data cleaning might be something called as a logical error. So if I go to our data, then I will show you what I mean. So if I go up here, then we have something called as this adult, children and babies information. So now what does these 3 column means is how many adults and children and babies were coming to particular hotel on that particular booking. So this is what this information means. So for example, for this first booking, and this booking was on the resort hotel, and here is the arrival date, time and everything, and at this hotel, the first booking right here, see here, at the first booking which was done on resort hotel, we got 2 adults, 0 children and 0 babies. So that means in the first booking only 2 adults came. Similarly, for this, let's say 13th booking, we can see that 2 were adults, 0 were children and 0 were babies. Now if you go down somewhere here, you will find that information where each of these values will be 0. Like for example, let me search and navigate right here. See here, right here, we have a data, and this field was for adult, and adult was 0, and this field was for children, and this field was for babies, and so on. So these 3 fields, all of them are zeros, which means that none of them came at this booking. There was the booking right here, this was the booking, and for this booking there was no adult, no children and no babies. That means who came here? No one. So this is the data that doesn't make any sense. Like no one came and still there is a booking, and there is something that is like they came, their departure date and everything. Maybe while filling this data, the data person made some mistake while filling this data. Maybe there was some adult coming, maybe there was some babies, but for now it is just 0. Maybe here is a typo or something, but we don't really care because this is not what we want. We don't want falsified information given to our machine learning algorithm. So this needs to be cleaned. So that is what we are going to do in this video. So here what we are going to do is we are going to check if we have children, adult and babies all value 0. If all of them are zeros, then that doesn't mean that someone came. So if someone didn't came, how come that there is a booking and their information about like maybe their country, maybe their previous cancellation, how could their information be? Because no one came. This information here, adult, children and babies, represents how many adult came in that booking and how many children came. But if all of them values are zeros, that means no one came. And if no one came, how come the information for them would be right there? So we need to clean that. So for that, I'm going to say that list column, and I will make children. That means we are just writing these 3 attributes on our list so we can filter it out. So next one is adults, and third column was babies. Now this is the columns list. Now I will loop around these list columns that we have just made, and we will get the children first, and then adult, and then babies. So after getting them, I want to print if they have unique values. So let's say I will format it maybe. So I here children, I here means children at first, and then the value of I will be adult at next iteration, and then babies has unique values is. Now I will define the unique values right here. So the unique values will be defined by unique. This is the function. Now if I print this, then you can see children has the unique values, that is 0, 1, 2, 10 and 3. And in the case of adult also there is 0, and in the babies also there is 0. What if all of them had 0 value at once? Then that is a problem. If adult has some value not 0, and children will have 0, and babies will also have zeros, then that's fine, because some of the adult came there in that booking. But if all of them values are 0 at once, then that is a problem. If all of them values are 0, then that means no one came. And how could be that information right here if no one came? See here, this was for the children, and this was for adult, and this was for babies. Now all of them information is 0, that means no one came. And if no one came, how could their information be like when they came, like they came in 2015 in October? Who came? No one came, right? See here, no one came. How could their information about country be here? Does it make sense? Like no one came and we have information about their country. So that needs to be cleaned now. So for that we will go down and create a next chunk here where we can just clean this information, clean the data, and this is the next step that we are cleaning. And the cleaning here will be like we can filter out this data. So I'll say filtered data after we clean those type of data. So how could we clean those type of data is, first of all we need to access those attributes which have the value 0. Like if I get children, like children, and this is the column that I am accessing, and if this has the value 0, if that has the value 0, then I'll just show you right here. Then you can see we will get the information if the children value is 0 or not. Similarly, I will check for those columns of adults which have the value 0 in their rows. And again, the last one is for the babies. Babies is equal 0. So this is what we have done right here. Let me put some brackets in order to just differentiate each of these conditions. So here at first, see here, we are checking on those rows where the children attributes will have 0 values. And there is AND right here. See here, do we have this AND? AND means all of them should be true. Like children will also have a value 0, adults also have a value 0, and babies also have a value 0 at once, then this will be true. And if that is the case, we don't want that data because that is dirty data. This is logically incorrect. This is no one came. No one came right here. And another condition also, it might be like if the children is 0 and adults is also 0, but babies has some value. Does it make sense? Like babies came all alone on our resort and on our city hotel. Does it make sense? Babies will only come with their parents, like with their adults. So we can also just purify it or make it clean by that way. But here we can see one condition where we checked if no one came. If we have a data that says if no one came, then if that is the case, I will give it inside the filtered data. And now here we are going to filter our data frame, and let us store in our data. Maybe I can say like final data. This is our final data now after cleaning, and our actual data was data frame. If you remember, we have this data frame that was cleaned previously by just replacing the null values. Now we take the same data frame and we filter it out. And if I want to filter it out, I'll just give this condition filtered data. So here this sign is a tilde sign, and this means we can filter it out. So if you do something like this, if you remove this tilde, then this final data will contain only those data which condition is true. So basically it means that if this condition is true, like if the children is also 0, adult is also 0, and babies are also 0 all together at once, then we will get this data by this condition and we will assign it right here. So that is not what we want. We want only those data where this condition will be false. We don't want this condition data on our final data frame. This is ambiguous data. This is dirty data. And we don't want this dirty data on our final data frame. So that is the why we need to filter it out. So for filtration, we use this tilde. So it is kind of a negation. We don't want this data. Rather, we want opposite of this condition. So now finally we have our data. If I run it, and now we can check it out, our final data. Maybe we can take the shape of our data. Let's say final data dot shape. If I run it, then we can see that we have now 11,90200. Like this is 119,210. Initially, before cleaning, if we go up and check the shape, then we have this many data. Now after pre-processing, we almost remove data more than 100 maybe. So maybe that was by this process. So about 100 data were there which contains this kind of information. You can also just clean your data by just saying what might be a scenario, like if baby came alone, is it real in our scenario case? It is applicable in our real world. Does it apply in our real world that baby came alone in our city hotel? So we can also pre-process and clean those data which doesn't make sense in our real world. Maybe this was the problem of the data entry person. Maybe he entry some of the ambiguous data, maybe there was some typo, some mismatched interpretation and information, and that was the case. While entering this data, we found these ambiguous decisions. Now, finally, we found a data that is cleaned. Now, from next video onward, what we can do is we can use this data for our analysis. Like we can analyze how many guests came, where do the guests come from, and similarly we can also do spatial analysis. We can check how many guests and how much do guests pay for room per night. How does the price per night vary over the year? So much interpretation, real world interpretation about the hotel booking can be done onto our project, and we are going to see couple of those interpretations and analysis in the next video.